Plans to talk through the 2014 No Calculator Free Response questions. As I go through them, we're going to talk through how to translate words into calc phrases, definitions, theorems, all that kind of good stuff. So it'll be more than just going through and giving you the answers. It'll be a little tutorial as we go along. So let's get rolling. So question number 3. So there's going to be 4 questions, 15 minutes-ish per question. There's 60 minutes total. So let's get going. First one, we have a function given, defined as e to the 2x. We're looking at region R, and we have a vertical asymptote that helps define or bound our region. So question A, write an equation for a line tangent to the graph at F. Anytime you see that, equation of a line tangent to the graph, I need 2 things. I need a point and I need a slope. So the first thing I need to know what is f of 1. First step. So I'm going to take 1, plug it into x, and f of 1 is e to the 2nd power. Okay, next thing I need, slope, derivative. So what is f prime? So f prime of x, derivative of e to a 2x is e to the 2x times, using chain rule, the derivative of the inside function, which in this case is the exponent 2x. So I have f prime of 1 then being e or 2e squared. Okay, I have my point, I have my slope. Let's use point slope form. Y minus y1 equals m times x minus x1. Do a little rearranging. That's actually probably fine. You can leave it just like that. Remember, you do not have to rearrange. You do not have to write it in any special form. They just said the equation of a line tangent. There's the equation of a line tangent. If I were to start rearranging and made a mistake, I would not get credit for what I have here. Okay? I would not get full credit for what I have here. So make sure you are, if you choose to rearrange, which I would not encourage, just leave it like that. If you choose to rearrange, just make sure you do it correctly. Okay, there you go. There's question A. So, question B, find the area of R. Sorry, I'm gonna have to scroll back and forth a little bit because it won't all fit on the same screen. Area of R. Think Riemann sum. When I write my integral, I am adding up the area formula. And the area formula is base times height. Well, my base we know is my thickness of dx. So then the height of this is going to be simply the y value of my function as x changes. As x changes from 0 to 1. As x goes from 0 to 1, my y value, or the height of my rectangle, will change. So there's my basic setup. So the area of R is going to be the integral of 0 to 1 of f of x, which was e to the 2x, and my thicknesses of my rectangle are dx. You must have the dx, you must have the function, you must have the upper lower bound. Okay, actually find the area, so integrate that. So integral of e to the 2x is e to the 2x, but then the derivative of the inside function would have given me a 2. My original function didn't have a 2, so doing an informal u substitution, I'm going to put a 1/2 in front. I'm evaluating that from 0 to 1, and so I have 1/2 of e to the 2nd power minus e to the 0 power. Make sure you have the parentheses, because that e to the 2nd power, or the 2x, became 2 terms, and the 1/2 needs to be included in both of them, either in front with a parentheses or individually with each one. And you're done. You can leave it like that, but if you want to rearrange it, e to the 0 power is 1, and when we distribute it, we get that there. This one right here is fine also. It's not the calculator part where you have to go to the nearest thousands. Okay, you can leave it in either format. Okay, question C. R forms the base of a solid whose cross sections perpendicular to the y-axis. That's important. Perpendicular to the y-axis. Right, but do not solve. So I'm just going to quickly throw a quick sketch in here of what we had. So there's my function. This up here was 1, and this up here is e squared, and this is 1. So I don't have to go back and forth. So now my rectangles, which no, they're not rectangles, they are squares. So my squares now are perpendicular to the y-axis. So this is the base of my square, and the height is the same length. Okay. This is going to be stacked in there with a dy thickness. So we're going to slide in these horizontal squares. My definition will change when I get to the 1. At 0 to 1, my integral is simply the length of this square, which is just 1. Okay? But then to that, I need to add the other one. Now we're going to integrate from 1. We're going to start from here now, and we're going to slide squares in all the way up until I get to, whoops, that's a squared, e squared. So here's the other thing. We had y equals e to the 2x. We need to rearrange that to solve for x. So going back to some pre-calc, we're going to take the natural log of both sides, or you could say you're going to switch forms, either way. And y equals 2x. Whoops. And so ln y, not y, ln y equals 2x. The 2x comes in front, ln of e is 1, and so I just get 2x. Okay, so then we have final equation, 1/2 ln y equals x. So over here, this becomes 1/2 ln y dy. Integrating from 1 to e squared, where my length of my square is 1/2 ln y. And then I want to take that thing and square it because I'm multiplying it by itself, because the area of a square is length times width, or s squared or x squared, or whatever you want to talk about. Okay? All right, there you go. Question 3 wasn't so bad. Question 4. The continuous function f is defined on the interval -5 to 8. Graph is given as f, so make sure you pay attention. That is f. Pay special attention to whether it's derivative you're given, whether it's a function you're given. We have this new function g with a different definition. Anytime I'm given a function in terms of an integral, I always just take the derivative really quick. So g prime of x is equal to 2 plus f of x. Derivative of 2x is 2. Derivative of an integral, take the upper bound, plug it into the function, multiply it by the derivative of the upper bound, which in this case is just 1. Okay, just for the fun of it, g double prime is equal to f prime. Okay, that's some important information. Find g of 0. Well, g is defined to be the integral from a -2 to 0 of f of t. Well, f of t is on the screen or on the graph. So what is, oh, I forgot. Well, plugging in 0, the 2 times 0 is 0. So this part here goes away. So I don't really need that, but I technically need to plug it into there also. So -2 to 0. I'm integrating from a -2 to 0, which means the area under the curve. Well, that looks like a basic trapezoid. So 1/2 height, which is this distance along the x-axis, which is 2, times base 1, which is either one of them, I'll go with the 2, plus base 2, which is the 1. So this distance plus that distance. 1/2 of 2 is 1, 2 plus 1 is 3. Next one, g of -5 is 2 times a -5 plus the integral from a -2 to a -5 of f. Okay, so g of -5 equals a -10. Now, I'm integrating from a bigger number to a smaller number, so I need to flip those, which means I need to change its sign. So the integral from a -5 to -2, the area under the curve from a -5 to a -2. So this distance is 2, this distance looks like 4, but I covered up, is 4. 2 times 4 is 8, but then take half of that. So this here is 4, but it's below the x-axis, so it's negative. This distance here, or this little triangle there, is 1/2 base times height, so that's a +1. So the net result of this guy right here is a -3. So I have a -10 minus a -3, which equals a -7. And so g of -5, I'll just kind of summarize, g of 0 equals 3, g of -5 equals -7. Okay, letter B. Find g prime in terms of f. G prime in terms of f. Well, we already did that up here, so I'm just going to rewrite it. G prime of x equals 2 plus f of x. Okay? Now, for each g prime, double prime of 4, and g double prime of a -2, find the value or state they don't exist. So g double prime, we already said right here, is f prime, and f prime is the value of the, the slope of the function at x equals 4. So looking at x equals 4, it looks like it's down 1 over 1. Let's jump up here. We're going down 6 over 6. My slope looks like -1. Down 6, right 6, -1. So g double prime of 4 equals a -1. G double prime of -2. That would be the slope of my given function at -2. This right here is a cusp or a corner. It's a abrupt change in my derivative or my slope. This one does not exist. Question C. On what intervals, if any, is the graph concave down? Concave down. G double prime needs to be less than 0, which means f prime needs to be less than 0. Right? Because we said back here, g double prime is the same thing as f prime. So where is my derivative decreasing? Okay, let's double check what the question was. On what intervals, if any, is the graph of g concave down? Concave down. Second derivative, negative, meaning f prime is negative, meaning my function is decreasing. So from -2 to 0, and from 2 to 8. From a -2 to 0, and that's a less than, and from 2 to 8. Why? Concave down means G double prime less than 0 on this interval. Okay. It wouldn't hurt to say f prime is decreasing, which implies G double prime is less than 0. Because technically that's how we knew. When you're asked to justify, you need to explain your thought process. What was it about this graph that allowed me to answer the question? What was it about this graph that told me the graph of G was concave down? The fact that G or F was decreasing over that interval. And that's what told me that must mean that the derivative is 0, which means the second derivative, or G double prime, is equal to 0. Okay. Question D. The function h is given by that function. Find h prime of 1. First step, what is h prime? So h prime, I see an inside-out function. I see a chain rule. So I have g is on the outside. So g prime, leave the inside alone, times it by the derivative of the inside function. So h prime of 1 equals g prime of 1 plus 1, which is 2, times 3 times 1, which is 3. And g prime of 2, going back up to remember our definition, g prime of 2. So here's g prime. G prime of 2 is equal to 2 plus f of 2. And up here, f of 2 is 3. F of 2 is 3. There's my definition for g prime. It's 2 plus f of 2. So g prime of 2 equals 2 plus f of 2, which we said was 3, times 3, which is 5 times 3, which is 15. Excuse me. Okay? Super important. Notice how many times we use this idea right here. We use that right there. Almost every problem. Super important that you can transfer a function into a function in terms of a integral into a derivative, into a second derivative, and that kind of stuff. Okay, question 5. Particle x moves along the x-axis, the positive x-axis, so that its position at time t greater than 0 is given by that big equation. Is the particle moving towards the left or towards the right? When you read this kind of question, there's a lot of these kind of questions on the tests. Be careful with the wording. In this situation, they're simply asking, is it moving towards the left or the right? Sometimes I've seen it asked, is it moving towards the origin or away from the origin? A twist to that question. It's not a different question, it's a twist to this question. In this case, I don't need the position. Okay? Doesn't matter if I start to the left of the origin, start to the right of the origin, it doesn't matter. But if I'm talking about, is it moving towards the origin or away from the origin? The position where we start matters. Okay, so in this case, moving left means my derivative, or my x prime, is less than 0. And if it's moving right, that means my x prime is greater than 0. So my first step then would be to take the derivative. So I get 3 times 5, decrease the exponent by 1, 9 times 2, and derivative of a constant is 0. Plug in 1, x prime of 1 equals 15 minus 18, which is a negative 3. H prime of 1 is less than 0, which implies therefore, hence, because. Okay, make sure you're connecting your statement with how you know that. So since this is the case, it is particle x is moving left. Okay, since my position's derivative, or the rate of change of the position, is negative, my particle is moving left. At what time, t greater than 0, is a particle furthest left? Well, if it's moving left at time equal 1, then I need to find out when does it change directions. So go back to our derivative we just found. So x prime is 15t squared minus 18t. I'm going to set that equal to 0. I'm going to factor out a 3t, and I get 5t minus 6. And so at t equals 0, and at t equals 6 over 5, my particle is at rest. We don't know if it changes directions. My particle's at rest. Take a little number line to see if it switches directions. At time equals 0, at time equals 1 1/5 or 6/5. Again, we have one way of doing these is to plug in values to the right, to the left of each of these zeros, and just see if it's positive or negative. Let's use a little bit of our graphing skills. I know I have a positive leading coefficient. My parabola, if I were to draw this as a parabola, would be right side up. When it's above the x-axis, it's positive. When it's below the x-axis, is negative. So I don't even have to plug in points. I quickly can see that it's positive above 6/5 and it's negative below 6/5. It's traveling to the right. It's traveling to the left. So if my particle traveling left the entire time from 0 to 6/5 and then it switches and goes to right, this must be a minimum because it goes left and then right. So it must be the furthest left at time equals 6/5. So since the particle travels left from t less than 6/5 and greater than 0, and then right when t is greater than 6/5, the particle is furthest left at t equals 6/5 seconds. Okay, I don't actually remember if there was in seconds. Nope, not seconds. T equals 6/5 units of time. We don't know seconds. Okay, question C. Second particle, y, moves along the positive y-axis. Okay, so here we go. We got a particle, y, sitting up here. So that its position is given by that equation at some point in time. Particle x is still sitting over here on the x-axis. Origin, position of the particles form a triangle. Find the rate of change of area. So my first thing is area equals 1/2 x times y. Find the rate of change of the area. So I'm going to just take the derivative. With respect to time, I'm going to call 1/2 x my first term. So derivative of the first is 1/2 times dx dt. Derivative of the first times the second plus the first times the derivative of the second. Okay, there's my equation. Now let's figure out what we know and what we don't know. At the time t equals 1, so y of 1 equals 7 plus 3, which is 10. So y equals 10. dx dt, well, I gotta go to my equation, which we did earlier, right? We already knew. I'm gonna write that down from earlier. X prime of t equals 15 t squared minus 18 t, right? And we found it at 1 back in question A, and that came out to be a -3. So we already know that one. And you could have gone back to question A and grabbed it. Just wanted to refresh our memory of where it came from. Okay, plus 1/2 x. At time equal 1, we already did that also. X was 3. And if we aren't sure, x of 1 is equal to 9 or 5 times 1, which is 5, minus 9 times 1, which is 9 plus 7. 12 minus 9 equals 3. Okay, dy dt. Well, that one's easy. That's just 7, right? Going back to here, dy dt is just 7. Everything's filled in. Let's work it out. Half of 10 is 5 times 3 is a -15. Half of 10 is 5 point, no, not half of 10. Half of 21 would be 10.5. Magic number, -4.5. So the question is, find the rate of change of the area, -4.5 units squared per units time. Show work that leads to your answer. This does not say to justify, so we don't really have to do any writing, but we have work that leads to our answer. We have all of our calculations over here, and so on. Now, if you look at the AP scoring guidelines, which I have a link in the description, if you look at those scoring guidelines, they did not do it this way. They changed these two equations with, or substituted them with the expressions that were given by X and Y. Totally fine. Okay, this is how I saw it right away, so that's how I did it, and it works great. Now you have two ways of doing it. Question 6. Consider the differential equation given. Y is going to be our particular solution with the initial condition that f of 1 equals 2. Okay? Find the slope of the line tangent. Looking at the derivative. Well, I've already been given the derivative. At x equals 1, y equals 2. So I'm just going to plug in my points. X equals 1, y equals 2. 2 divided by 1 is 2. 1 minus 2 is a -1. 2 minus 1 is a +1. Multiply those, and I get a -1. Pretty straightforward. Those are nice, especially at the end of the test on question 6, to have a 30-second super easy question. Okay, this one's not much worse. This one's okay. dy dx, I got to rewrite it because we got a lot of calculations here that we're getting ready to do. Slope field. Let's draw a slope field. So I kind of like just to pick a value for x and then run them. Pick a value for y and or pick a value for y and run them. I'm going to go with x. I'm going to start with x equals -1. This expression here is a +1, right? So I get 2 divided by 1. So I get 1 minus 2. So when x is a -1, that first part is a -1. Now let's adjust. When y is 0, like on the origin or on the axis, y is a -0, that's a -1, and this becomes a +1 slope. I'm aiming up for that point up there, +1 slope. Okay, when x is a -1 and y is 1, well, let's get that taken care of. When y is 1, every one of these will be horizontal. That one's easy. Okay, when y is 2, now this becomes a +1, not negative, and my slope is just -1. Okay, on the +1 side, this doesn't change, so this number is still a -1. But now y is still 0, so this is just going to repeat, right? It's the same slope. Whether x is a +1 or -1, that doesn't matter. Okay, when x is 2, I get 1. I got to get myself some, no, we'll go over here. So I get 1 minus 2 over 2 squared, which is 1/2. 1 minus 1/2, which is 1/2. All right, now let's work our way through. When y is 0, That's a -1, so this becomes a -1/2. So we're going to go this direction, shooting up for that 1 up there. Probably a little bit long. So we're going to shoot something like that. Shooting for this 1, right? That's my 1/2 slope. That's kind of what we're shooting for. Okay. We already did the 1, so when x is, or when y is 2, that becomes a +1, and so my slope, same slope, but positive. That wasn't too bad, just some calculations. Question C, the big one. Find the particular solution y equals f of x to the differential equation. Guaranteed you've seen this along the way. So I'm going to be very careful, using good notation, staying organized, and let's walk through this. First step, when you have a differential equation, you're trying to solve a differential equation, you have to separate your variables. Put the y's and dy's on one side, x's and dx's on the other side. So the y minus 1, I'm going to divide both sides by y minus 1, it slips underneath the dy. I'm going to multiply both sides by dx. I've separated my variables. Okay, integrate to find the particular solution. We have a differential. We want to go backwards to the original. We integrate. The derivative of what function gives me 1 over y minus 1? Well, that'd be ln. Derivative or integral of 1 is x. Think of this as negative 2x to the negative second power. The rule I use is I add 1 to the exponent. So a -2 becomes a -1. I divide the old coefficient of a -2 by a new exponent of a -1, and I get a +2. Add 1 to the exponent, divide the old coefficient by the new exponent. That's the rule I use in my head. And when I talk myself through it, add 1 to the exponent, divide the old coefficient by the new exponent. Okay, and then the all important plus c. I have a general solution. Find the particular solution. Use my initial condition. So plug in 2 for y, plug in 1 for x, plug in 1 for x, and solve for c. Now, you can solve for c anywhere down the process. I could have solved this thing all the way down to y equals with a c in it and then plugged in the 2 and the 1. Sometimes one way is easier, sometimes it's easier to do it early. Okay, I'm going to do it early in this case. So natural log of 1 is 0. So that becomes 0 equals 1 to any power is just 1. So 1 to the -1 just means 1 over 1. So that just is a 2. 2 plus 1 is 3. Subtract 3. C equals -3. Equation. ln of y minus 1 equals x plus, I'm going to rewrite that as 2 over x. And c was a -3. Solve for y. I do need to get the y out of there. So remember, we did it several times already. E to this power, so y minus 1 equals e to the x plus 2 over x minus 3. You can leave it like that. I'm just going to add 1. Remember though, if you choose to simplify, you need to choose to simplify correctly. Okay, because if you made a mistake, if I subtracted 1 for some weird reason, I would not get full credit. So if I choose to make it y equals, I need to make it correct y equals. Okay, there you go. There is the No Calculator free response questions for the 2014 exam. And if you found these helpful, check out the other three I have on the other 3 parts. And we'll catch you later. Thanks for watching. If you found these videos helpful, you can find other videos in my series. And don't forget the reviews where I talk through a bunch of practice problems. Have a great day.